Okay, hello and welcome to this video. My name is Wade Smith, and in this video, I'm going to do an easy debunking of the Planck limit as a real limit in the universe. Um, First of all, let's discuss something that Stephen Hawking fell into a trap, and he was aware of the trap and fell into it anyway. It's called model. Let me put my hands up here for quotation. Model dependent reality. Model dependent reality is when the physicist starts incorrectly reinterpreting reality through their model rather than reinterpreting the model through reality. And let's give an example of this. When physicists and astronomers see something on the far side of the universe, they think they understand through their model what they're observing. And then they reinterpret what they're observing through their model. Oh, well, we think we just found the population 3 stars. How do you know? You've never been over there on that side of the universe to know what's actually there. You're looking at something so far away that if even the slightest thing is wrong with your model, you're not even looking at what you think you're looking at. All right. So that's model dependent reality. It's a fallacy. It's a fraud. Um, Incidentally, all of Stephen Hawking's theories have since been disproven, except Hawking radiation, and that might get disproven eventually too. Um, but anyway, so the topic is the Planck limit. The Planck limit cannot be a real limit in the universe because the definition of a circle and the definition of a triangle contradict there being a Planck limit. For example, if I drew a right triangle, I believe it's isosceles is when you have both sides of a right triangle being the same length. Well, if we made both legs of a right triangle the Planck limit, then we would have a contradiction because the hypotenuse would be a length that is not an exact multiple of Planck units. Or if we made the hypotenuse equal to one Planck limit, we would have a contradiction because both legs of the triangle would be smaller than the Planck limit. So I can easily disprove the Planck limit as a real limit in the universe just using the definition of a right triangle. Same goes for a circle. If there was such a thing as a Planck limit, it wouldn't be possible for a circle to be continuous and have a point in every direction from the focus, because there would be a limit to how many points you could have in a circle. So I just disproved the present version of quantum mechanics, believe it or not, because it's heavily dependent on the Planck limit, which does not exist and is not a real limit in reality. It's shocking the amount of fraud that goes on in physics in the standard model that passes for science when there's nothing to it. For example, about 10 years or so ago, I saw Dr. Amy Mainzer trying to explain the Big Bang model and trying to explain because the Big Bang model falsely predicts that there should be as much antimatter in the universe as there is ordinary matter. And Dr. Amy Mainzer was stumped by this because she got asked about it on an educational program, and she tried to claim that the antimatter went somewhere else. Like, where? There's nothing but the universe. The word universe means everything. According to Carl Sagan, your hero atheist, the word universe or cosmos means everything that is and was and will be. There is only one universe. So the antimatter couldn't magically go somewhere else. But that was her attempt to explain antimatter. In my version of the story, there is an almighty creator, and he did not make that much antimatter in the first place because the Big Bang model is in fact wrong. Yes, the universe is in fact expanding everywhere we look and for all time, but there is no reason to believe that the universe came from a single point, because that's a contradiction. That would be a black hole, and not even light would be able to escape the black hole. There's absolutely no reason to believe in symmetry breaking. One of the laws of logic states that the laws of the universe and the laws of reality, the Copernican principle, in fact, states that the laws of the universe are the same for all of space and time, and that we do not occupy a special place in space or time. All right. So the Copernican principle is what all modern science is supposedly based upon, and yet some of these crackpot physicists want to talk about so-called symmetry breaking, whereby they claim that the laws of physics were unified at one time and then broke down into modern laws somehow during or shortly after the Big Bang allegedly happened. There's no evidence of that in the physical universe. As I explained to someone just a little while ago on Quora, if the laws of the universe could change, you wouldn't be able to study anything anyway. And as a matter of fact, your body, every particle in your body would instantaneously be destroyed. Even the photons would be destroyed if the laws of physics changed in the least a bit, especially if they actually divided into more and more laws that are no longer somehow related to one another. That doesn't even make sense, but that's what they're claiming symmetry breaking means. Um, Oh, I've studied all of this stuff. I read everything by Hawking. I read, especially in an attempt to debunk him, which I very much so did. Um, I read everything by so many of these physicists and mathematicians. So I'm well versed on all of that. Uh, but yeah, there's no such thing as a Planck limit. That's pseudoscience. There is absolutely zero evidence of a Planck limit, and even if there was, there would be no way to test it. So that's what mighty convenient that they call it science, and yet there's no physical way to test it, because the number is already so small that it means nothing in the macroscopic world. But there is, in fact, no such thing as a Planck limit. There's no such thing as a smallest possible number greater than zero. Zero is technically not a number. Zero is the absence of a number. But there is no such thing as a smallest possible number greater than zero, because you can always do 1 divided by infinity, which is not zero, by the way, but approaches a limit where n equals infinity, where the limit is zero, but the value is not zero, because infinite limits do not exist. All right. I think I've explained that pretty closely. In other words, the limit exists, but the value at the limit does not exist, is what I'm trying to say. Uh, and that limit is zero. It is not the Planck limit. So anyway, they're totally wrong, and that totally invalidates much of the standard model of particle physics and much of quantum theory, which is why they never seem to be able to do anything useful with quantum computers. The only thing they can do is solve problems they already know the solution to, which doesn't even prove quantum theory works. Anybody can solve a problem they already know the answer to. And as the saying goes, even a broken clock is correct twice a day.